Alright, 2.6 screencast. Polynomial inequalities. I believe this is the last lesson for the chapter, so that's awesome. So polynomial inequalities can be written in the form f of x is less than 0, f of x is greater than 0, or f of x is less than or equal to 0, f of x is greater than or equal to 0. Based on the inequality symbol, the solution is the portion of the graph which is either above or below the x-axis. Alright, so for instance, if, in this example, if I had f of x, oh my gosh, if I had f of x is greater than 0, well, that would mean it would be this portion. Let's see, only the portion which is greater than 0. Alright, so I would have this is equal to negative infinity to 1, 2, 3, negative 4. Because this is my origin, right here is my origin. It said 0, 0. To 4 union negative 2 to 2. Yeah, negative 2 to 2. That's it. If I said f of x is greater than or equal to 0, it would be similar except for this point right here, because that's where it's equal to 0. So I have negative infinity to negative 4, and this time I'm including that it touches union square brackets now all the way, union 5. Because just at that x equals 5 portion, that's where it's touching 0. That's the only point where it's like equal to 0, because it goes down after that. Okay, the other, if I want to do f of x is less than 0, well, it's this portion, and this portion. So this would be negative 4 to negative 2, union 2 to 5, 2 to 5, and of course all of these are parentheses, and then 5 union 5 to infinity. Because at 5 it equals 0, which in 0 is not less than 0, so I have to have this like spacing right here. Okay, what if f of x is less than or equal to 0? Okay, so I actually can square bracket my negative 4 to negative 2, because that's where it's equal to 0, union negative 2 to infinity. Because I include it here, 5 is included, and then I just keep going. So that's it. So how do we solve a polynomial inequality? Solve for f of x, plot the zeros on a number line to create a sign chart, and then test the values from each interval. Okay, this is fine. So step 1, solve. We want to solve the inequality. So I have x squared minus 8x plus 15. Let's see, because I want to subtract 1 from both sides. That way I can have it, set that equal to 0. Is less than equal to 0. So that means x minus 3, minus 5 is less than 0, because negative 3 plus negative 5 is negative 8. When you multiply them, you get positive 15. So I see x is equal to 3 and 5. Okay, so that's step 1. Step 2, plot a number line. Okay, so the stuff I have in question is 3 and 5, because that's where, I know it's 0. I know it's 0 between them. I'm sorry, I know it's 0 at 3 and at 5, because those are my zeros. Okay, third step, test values. So this tells me, because I'm literally trying to make like a sign chart, trying to decide if it's positive or negative. Okay, so I'm going to plug in a value to the left of 3. So I'm going to try x equals 2. Alright, so I have 2 minus 3 times 2 minus 5. Is that less than 0? We shall check. So 2 minus 3 is negative. 2 minus 5, well, that's negative. Negative times negative is going to be positive, so it's positive over here. Okay, let's try number between them. So x equals 4. So I have 4 minus 3 times 4 minus 5. Alright. Actually, I don't really care if it's less than 0. I'm just trying to see what the sign would be. Okay, so this is positive. 4 minus 3 is positive. Times 4 minus 5 is negative. So this would mean negative times positive is negative. Awesome. And then let's test a number that's bigger than 5. So x equals 6. So 6 minus 3 times 6 minus 5 is positive times a positive. It says to be positive. Okay. So what I'm wanting to know is where is this less than or equal to 0? Let's see, where is this less than or equal to 0? So less than 0, definitely here because that's negative, or equal to at 3 and 5. So my solution is going to be from 3 to 5, including them because those are my zeros, and the place in between them is negative. Thus, when it's negative, it's less than 0. Awesome. That's it. Whew. Okay, alright, let's go to the next example. So this one's not quite so straightforward. I wish. Okay, so let's get everything on the same side. So I have x cubed minus 3x squared minus 22x plus 24 is greater than 0. So I just moved these two terms over. Alright, let's see. I need to find the zeros, right? Because then I'll know what I should have on my number line, like which numbers. Like here, how I separate them because I know those were my two where y equals 0. Those are my two x-intercepts. So I need to divide. What do I divide by? Well, we know how to find our zeros, our possible zeros, right? P divided by Q. So it's going to be, because I have a negative 24 here. Well, my Q is just 1, so I can leave that off. So plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Alright, so this is tying together everything we learned so far. So we want to use this to find a factor. I'm going to try 1, because it's my first one. Whatever. So I'm going to test for like x minus 1. So I'm testing for x minus 1. Put 1 here. Okay, so 1, negative 3, negative 22, and 24. Okay, so that's big. Alright, so bring down the first coefficient, multiply, combine, negative 3 plus 1 is 2, multiply, negative 2, oh good, negative 24. Oh no, this is okay. Negative 24, okay, 0, awesome. So that is a factor. Sweet. Okay, so I have x minus 1 times x squared minus 2x minus 24. Can we factor that? I think so. X minus 1, okay, so it's x, what adds to negative 2 but multiplies to 24? 4 and 6. Question is, which one's negative? Since the middle part here is negative, I'm going to have this 6 be negative. Plus 4, yeah. Multiply 6 and negative 4 is equal to negative 24, but when you add them, you get negative 2. Awesome. Okay, so that's it. Found our factors. So I'm going to go ahead, draw my number line. So I have, let's see, x equals 1, 6, and negative 4. Okay. Negative 4, 1, 6. So I need to, I know those are where x equals 0. I'm sorry, those are where my y equals 0. So I need to find out, you know, is y positive or negative on each interval. Okay. So let's test some things. How about x equals negative 5? Let's test that. Let's test x equals 0, because that's between negative 4 and 1. Let's test x equals 2, and let's test x equals 7. Because I have 4 intervals, so I need to have 4 tests. Alright, So when x equals 5, oh my god. Oof. So I'll have 5 minus 1, 5 minus 6. Oh wait, shoot, this meant to be negative 5. Oh my god. Okay. Negative 5 minus 1. Negative 5 minus 6. Negative 5 plus 4. So that's negative, negative, negative. Okay, this will be negative. So negative times a negative times a negative is a negative. Okay, let's try 0. So 0 minus 1, 0 minus 6, and 0 plus 4. Negative, negative, positive. So negative times a negative is positive times positive. Okay, so that'll be positive. Let's try 2. So I have 2 minus 1, 2 minus 6, and 2 plus 4. So 2 minus 1, well, it's positive. This one's negative. This is positive. Okay, so that's negative. And last one. I have 7 minus 1, 7 minus 6, and 7 plus 4. Okay, so clearly all these values are positive. Alright, so I want to know when it's greater than 0. So clearly it's going to be these two intervals. So it's going to be from negative 4 to 1. Notice I'm not or equal to, so since I'm not including where it's equal to 0, so I have the parentheses in union with 6 to infinity. That's it. That's the whole problem. Awesome. Okay, and let's finish up. So this last part, okay, cool. So it's already written in terms of 0. I need to find the x-intercepts though. Issue, there's no numbers that multiply 3 but add to 2, so I'm going to use the quadratic formula. Just a refresher, quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. Alright, so plug in, see what you get, try this one out. Go ahead, pause the video if you need to see the work on how I did the quadratic formula. But the issue is, I didn't find any real solutions, so no real solutions. So here's my 0, so let's see, it doesn't cross. Plug in an x value, it's going to be positive. So it's positive everywhere, and then I'm wanting to find where it's less than 0. So there's no solution, because it's never less than 0. Because I don't have any x-intercepts, literally what this looks like, it's going to be something like this. It doesn't touch the x-axis, so there's nowhere where it's less than 0, nowhere where my y value is less than 0. Alright, try the next one. So this one is, wow, the exact same problem. The issue is if it's greater than or equal to 0, well, we already know. We already know this one, right? Here's 0, it's positive everywhere, literally from negative infinity to infinity. That's where the solution is. Alright, part E. So x squared plus 12x plus 36 is less than or equal to 0. Okay, so let's try this out. So let's try factoring it. This is a perfect square trinomial, so x plus 6 squared is less than or equal to 0. So negative 6, I have the solution negative 6 twice. Interesting. So what do? It doesn't matter what number I plug into my x value, because I need to plug in values. Doesn't matter if I plug in like negative 90, right? X is equal to negative 90 plus 6 squared. Well, it doesn't matter what number, it's going to be squared, it's always going to be positive. Let's plug in, a positive number, once again, 90 plus 6 squared, whatever, it's positive. So the only place it's greater than or equal to 0 is negative 6. Literally, the only solution is negative 6. That's the only place it's less than or equal to 0, because that's the only place it's equal to 0. Okay, so that was relatively quick. Alright, so rational inequalities. It's one that contains a rational function. Well, we already know what that is. That's when you have two you're dividing literally two functions. Whereas a polynomial function only changes signs at zeros, a rational function can also change signs at its points of discontinuity. Therefore, the sign change chart of a rational inequality must also include the zeros of the numerator. Okay, so we're including the zeros of the, did I mean to say denominator? I think so, because I have to include any point that's like interesting. Okay, so recall rational equations. Go ahead, do this problem. Example 2, solve the following inequality. Okay, so what I want to do is multiply both sides by x plus 2, because I want to get this into a nice 3x plus 4 is greater than or equal to 0. The issue is, if I multiply everything by x plus 2, I literally, like, the x plus 2 on the denominator goes away. Alright, so my least common denominator was x plus 2. But the issue is, this means x cannot equal negative 2. Alright, so keep that in mind, x cannot equal negative 2. So we're just trying to use our rational equations information. Okay, so I'm solving for f of x. So I have 3x plus 4 is greater than 0, so minus 4 on both sides. 3x is greater than negative 4. So x is greater than or equal to negative 4 over 3. Okay, so we can do that. What if okay, I'm done with the first step. I need to draw my number line. So I have negative 4/3. Then I also have to include like my interesting points, aka negative 2, because it can't equal negative 2. Okay, so I need to figure out, I need to plug in points. So if I plug in, let's say x equals negative 3. Okay, so I have 3 times negative 3 plus 4 over negative 3 plus 2. So negative 3 times negative 3, so negative 9 plus 4 is negative 5 over negative 1. Okay, so this is positive. So it's positive when I'm less than 2. How about if I plug in negative 5/3? This is fine. Okay, so 3 times negative 5/3 plus 4 over, yikes, negative 5 thirds plus 2. So negative 4 plus 1. Let's see, I'm sorry, negative 5 plus 1, because this top 3's cancel out. So it's negative 1 over 2, let's see, 2 is equal to 6 over 3, so this is equal to like 1/3. Okay, negative. And then let's plug in x equals 0. That'd be a nice number. So I have 4 over 2, which is positive. Okay, so I'm trying to find where it's greater than or equal to 0. Alright, greater than or equal to 0 is going to be these two places. I can include like my zeros. So, but, x cannot equal negative 2. So, I'll go from negative infinity to negative 2, not including it, but I will include negative 4/3 to infinity. I can't include negative 2 because that was the bottom of my fraction, right? If x equals negative 2, the whole thing goes undefined. Okay, last problem. So, here the least common denominator is going to be x minus 2, meaning x cannot equal 2. I want to multiply everything by x minus 2. Multiply by x minus 2, crosses out here, I still have x minus 2 over here. Okay, so x squared minus x minus 11 less than equal to 3x minus 6. Move everything over on the left side. X squared, move left side, minus 3, okay, so minus 4x. Add 6, so it's negative 5 is less than equal to 0. I can factor this is fine. Okay, so x minus 5, x plus 1 is less than equal to 0 because those are the only two numbers that add to negative 4, multiply negative 5. So x can equal 5 or negative 1. And so when I draw my little number line, I have to include, let's see, 1, my interesting point, which is x equals 2, because it can't equal 2, and 5. Okay, just need to plug in some numbers. So if I plug in negative 2, if I plug in x equals negative 2, I will get, let's see, negative 2 minus 5, negative 2 plus 1, so it's going to be negative. If I plug in x equals 0, 0 minus 5 and 0 plus 1. Oh, wait. Did I mean negative? Yeah, I did. Because that was plus 1, negative. Yeah. Negative times negative is positive. Oh, shoot, did I mess up? Plug in 0 should be negative. I'm sorry, plug in, this is negative, so it should be positive. And x equals 3. Okay, 3 minus 5, 3 plus 1. Okay, so once again, this is going to be negative. Yeah, so it'll be negative. And then last one, let's see, plug in maybe like 6. 6 minus 5, 6 plus 1, that's going to be positive. Okay, so where is this? So going back, I want to know, where is this less than 0? Less than equal to 0. Less than equal to 0. Here. So the solution has to be, I want to equal as well. Okay, so I want it to be negative infinity, negative 1, I'm including, negative 1 to 2, remember x can equal 2, 2 to 5, and that should be it. Cool. So remember, it's going to be square brackets when you have a less than or greater than, parentheses when you have less than greater than. You have the or equal to square, otherwise that's it.